In this video, I'm going to show how to solve inequalities using sign graphs. The method I used you may not have seen before. Here's our first problem. Let's find values of x that make this inequality true. Let's start with a sign graph for x minus 3. So the way you start this is let's find what makes x minus 3 equal to 0. So x minus 3, set that equal to 0. And to solve that for x, you just add 3 to both sides. And we get x equals 0 plus 3, or x equals 3. And you plug in 3 for x, you're going to get 0. So I'm going to mark that on our sign graph here. Where x is 3, the value of x minus 3 is 0. So now what you want to do is find what the signs are going to be on either side of 3. So let's try 4, and we'll also try 2. So we'll start with 2 first. So in the expression x minus 3, we're going to plug in 2 for x. If you plug in 2, you get 2 minus 3 equals negative 1. So when you plug in 2 into this expression, we're going to get negative 1. So that means that for values smaller than 3, the sign of x minus 3 is going to be negative. Now if we plug in 4 for x, you get 4 minus 3, which equals 1. That's positive. So for values greater than 3, like 4, x minus 3 is going to be positive. Now let's move on to the next factor, x plus 2. Let's do the same thing for this one. So we have x plus 2. If we set that equal to 0, if you solve that for x, subtract 2 from both sides, and you get x equals 0 minus 2, which is negative 2. So at negative 2, which will be somewhere over here, x plus 2 is 0. That makes the expression x plus 2 be 0. Right, so now let's plug in some values on either side of negative 2. Like let's try negative 1 and let's try negative 3. I'll start with negative 3 first. So here's x plus 2. We're going to try negative 3 for x. So you get negative 3 plus 2 equals negative 1. So if you plug in values smaller than negative 2, like negative 3, you get a negative value. So for values smaller than negative 2, you got a negative here. Now let's do negative 1 now for x. X plus 2, I'm going to plug in negative 1. So you have negative 1 plus 2 equals 1. That is a positive value. So for values greater than negative 2, like negative 1, or anything to the right of negative 1, it's going to be positive. Write that out there. Oh, another thing too, you want to make sure that these line up correctly. So on this first one, we have a 3 there, and then negative 2 is obviously going to be to the left of that. So make sure these line up, otherwise your sign graph is not going to be correct. Negative 2 is obviously to the left of 3. Next, let's do the factor x minus 7. Alright, so let's find what value of x makes x minus 7 be equal to 0. So you just need to solve that for x, so add 7 to both sides. X equals 0 plus 7, which is 7. So when you plug in 7 into this, you get 0. So we got a 4 here, so our 7 is going to be somewhere over here to the right. Sorry, this isn't the scale, but it's close enough. So yeah, for 7, you got a 0 for this factor. Okay, now let's plug in values to the right of 7 and to the left of 7. So we could try 8, and we can also try 6. So let's try 6 first. So you got x minus 7. If you plug in 6 for x, you get 6 minus 7 equals negative 1. So for values smaller than 7, like 6, we get a negative value. So anything to the left of 7 is going to be negative. This is all negative here. If you plug in 8 for x, we get 8 minus 7, which equals 1. 1 is positive, so for values greater than 7, like 8, or anything bigger than 8, or actually anything bigger than 7, it's going to be positive. The next step is to draw a vertical line through the zeros. Here's a 0 at 3. And we have a 0 here at 7. So we've got 1, 2, 3, 4 different sections here. If you look up here, these are all multiplied together. The factor x minus 3 times x plus 2 times x minus 7, that all multiplied together is greater than or equal to 0. So we got a negative times a negative times a negative is a negative. A negative times a positive times a negative is a positive. And here we got a positive times a positive, that's just a positive. You multiply a positive times a negative, that is a negative. And then over here in this section, we've got positive times a positive times a positive is a positive. We want to find the sections where this is greater than or equal to 0. So in other words, 0 or positive. The sections where it's positive are going to be here and here, where the product of all those factors is positive. And it can also be equal to 0. So we need to find out where it's going to be equal to 0. If any one of these factors is 0, the whole thing is going to be 0. At negative 2, at 3, and also 7, it's going to be equal to 0. We need to include all the endpoints here. So the way you write that in interval notation, this interval here starts at negative 2, and it includes negative 2 because it can be equal to 0. We're going to start at negative 2, and since negative 2 is included, you have a bracket. If negative 2 is not included, you have a parenthesis. This positive interval goes all the way to 3. And at 3, it's equal to 0, and that's part of the solution, so we need to include 3 as an endpoint. And then it skips ahead here. It's negative for a while. So you'd go union. At 7, it's going to pick up again. It's going to be 0 there. 7 is included. And then it just keeps going positive the rest of the way for all of these. You just say 7 to infinity. And we don't know where infinity is, so you put a parenthesis there. This is how you do interval notation. To graph this, what you do is you go negative 2 up to 3 and everything in between, and then at 7 you got a square bracket there too, and it keeps going to the right on to infinity. So I did interval notation and I also graphed it. Here's our next problem. You may notice that you can factor the numerator, so let's do that. So to factor a trinomial with a leading coefficient of 1, all you do is you make an x, and we're going to put the negative 6 on the top, and the number in front of the x, which is 1. If there isn't a number in front of the x, it's actually a 1, whether there's a number there or not. So negative 6 and 1. So you want to find factors of negative 6 that add to 1. 3 and negative 2. 3 times negative 2 is negative 6, and 3 plus negative 2 is 1. So then you just go like this. X plus 3x minus 2. So we're going to replace the x squared plus x minus 6 with what we just found there. If you need more practice factoring trinomials, I'll include some links to my videos. Now we have the numerator factored, so we're going to do sign graphs for each of these. Right? So let's start with x plus 3. So if you set x plus 3 equal to 0, you're going to find that negative 3 is going to make this be 0. So just to save time, I'm not going to go through all that. If you need to look at the first problem, I went into that in detail. So negative 3, that's 0. If you plug in something bigger than negative 3, like negative 2, negative 2 plus 3 is positive. So anything to the right of negative 3 is going to be positive. If you plug in something smaller than negative 3, like negative 4, negative 4 plus 3 is negative 1. So anything to the left of negative 3 is going to be negative. It just keeps going. All right, and then the next one we could do is x minus 2. If you set that equal to 0, you're going to find that at x equals 2, this is going to be 0. If you plug in values bigger than 2, like 3, 3 minus 2 is 1. 1 is positive. So numbers bigger than 2 are going to make this factor be positive. Numbers smaller than 2, like 1, if you plug in 1 here, 1 minus 2 is negative 1. So anything smaller than 2 is negative. Let's do one for x minus 4. If you set this equal to 0, you're going to find that x equals 4 is going to make that be 0. And if you plug in values bigger than 4, like 5, 5 minus 4 is positive. So anything bigger than 4 is going to be positive. Anything smaller than 4, like 3, is going to make that be negative. Then next we're going to draw vertical lines through the zeros. So we got some different sections here. Also, so the x plus 3 is multiplied by x minus 2. So these guys are multiplied together. And then we're dividing that result by the denominator. So you're going to divide that result by the x minus 4. Negative times a negative is a positive. A positive divided by a negative is a negative. So that section is negative. Here we got a positive times a negative. That's a negative. A negative divided by a negative is a positive. A positive times a positive is a positive. A positive divided by a negative is a negative. And in the last section we have a positive times a positive is a positive. A positive divided by a positive is a positive. Right? So we're looking for where this is greater than or equal to 0. So in this section it's going to be positive. This section it's positive. The only way this fraction can be 0 is if the numerator is 0. The denominator can never be 0. At negative 3 and 2, this can be equal to 0. So we can also include the endpoints negative 3 and 2. We cannot include 4. Because if you include 4, this is going to be 0. You can't have a 0 in the denominator. That's not allowed. We can have zeros in the numerator though. Where it's going to be greater than or equal to 0 are these sections here. So the endpoints negative 3 and 2, and in between them, and then larger than 4, greater than 4. Okay, so let's do interval notation for this problem here. It's going to start at negative 3, because at negative 3 it's 0, and then it's going to go to 2, negative 3 up to 2, and again negative 3 and 2 are included. They're included there where this is going to be 0 in the numerator, and where it's positive is going to be between those two, between negative 3 and 2, and then union is going to be positive greater than 4. Now we can't include 4 though, because that makes the denominator be 0. So you have to put a parenthesis for 4, and then it goes up to infinity, because way out here is infinity. And infinity, you always have a parenthesis for that. And if you wanted to do a graph of your answer, you could do it like this. So bracket at negative 3 up to 2. So in between those, negative 3 and 2. And then starting again at 4, we got a parenthesis at 4. And then it just keeps going to the right and it's not going to stop. So it's going to look something like that. Here's our last problem. Let's solve this for x. What you want to do is move the 4 over x onto the other side. So we'll subtract 4 over x. Then you just have 3 over x minus 2 minus 4 over x is less than 0. Next, what we need to do is get a common denominator. So the common denominator is actually going to be x times x minus 2. So we need to multiply the first one by x over x, and then you need to multiply the second one by x minus 2 over x minus 2. So then we have 3x over x times x minus 2 minus 4 times x minus 2 all over x times x minus 2 is less than 0. And they have the same denominator now, so we can just write it over one denominator. So you have 3x minus 4 times x minus 2 all over x times x minus 2 is less than 0. All right, so let's simplify the numerator. So you're going to have 3x minus 4x plus 8, because negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. That's all over x times x minus 2 less than 0. And 3x minus 4x, that is negative x plus 8 all over x times x minus 2 less than 0. We're going to do sign graphs for these. So here's negative x plus 8. Okay, as it turns out, where x is 8, this is going to be 0. And because the x is negative, it's going to be actually reversed. So if you plug in something bigger than 8, like if you have 9, you actually have negative 9 plus 8. That is a negative 1. So for values bigger than 8, it's going to be negative. If you plug in something smaller than 8, like 7, if you plug in 7 here, you get negative 7 plus 8. That is a positive 1. So anything smaller than 8 is going to be positive. Let's move on to x. Okay, what value of x makes this be 0? It's 0. If you plug in 0 for x, you get 0. Plug in something bigger than 0, like 1. 1 is positive. That's going to make this be positive. So anything to the right of 0 is positive. Anything to the left of 0 is going to make that be negative. Next is x minus 2. What value of x is going to make x minus 2 be 0? It's going to be 2. So you plug in 2 for x, that makes that 0. If you plug in something bigger than 2, that's going to make that be positive. Plug in something smaller than 2, it's going to make that be negative. So like for example, if you plug in 1, 1 minus 2 is negative. It's a negative 1. So anything smaller than 2 is going to be negative. Then we're going to do a vertical line through each of our zeros. Now this problem, we want to find where it's less than 0. So in other words, where it's negative. And also, I guess I should probably show these two are in the denominator. So we're multiplying those together, and then we're dividing the top by that product in the bottom. Positive divided by a positive is a positive. This one we got a positive on the top, and then you got a positive times a negative. That's going to be a negative. So a positive divided by a negative is a negative in this section. Here you've got a positive divided by a positive times a positive. That's a positive all the way around, so it's just going to be positive there. And then here we got a negative divided by a positive times a positive. That's just going to be a positive. So a negative divided by a positive is a negative. So the sections where we're interested in are less than 0, which is negative. That's going to be here and here. And we don't have less than or equal to 0, so we're not going to include any of the endpoints at all. You only want to know where it's going to be less than 0, so where it's negative. So the way we do that, let's say it starts at 0, and it does not include 0 because we don't want it to be equal to 0. We only want it to be less than 0. So 0 up to 2, that's the endpoint for the negative section there. So from 0 to 2, and then union, this other section starts at 8. Again, 8 is not included, and it goes up to infinity. Just keeps going. Put a parenthesis around that. And then the way you would graph that would be like this. So here's 0, here's 2. So you include the points in between there. Starts again at 8, and then it just keeps going up to infinity. Thanks for watching.